Welcome back to the Fundamentals of CRBasic Programming video series. In this video, I will demonstrate using programming loops to repeat a task multiple times without adding a lot of code to a program. Programming loops are one of the most powerful tools available in computer programming because they allow tasks to be performed as quickly as possible at precise time, and they shorten the amount of code required by writing the code once and then reusing the same code as many times as needed. CRBasic includes different types of programming loops, including for next, do loop, loop until, and loop while. These instructions are found under the Program Structure and Control category in the CRBasic instruction panel. I will start by demonstrating a for next loop in a simple program that measures the data logger panel temperature and a thermocouple once a second. For next loops are used when a task needs to be repeated a specific number of times. I will add a new variable called loop test, which I will use to demonstrate how loops work. I will also add a variable named counter that I will use to configure the for next loop. Since the counter is an integer, I will declare counter as type long, which is an integer. Now I'll set up a for next loop to repeat a task in the program. First, I add a for statement on one line and next on another line with some blank lines between them. Any task I place between for and next will be performed each time the program cycles through the loop. Now that I have a for next block, I will use an expression to configure the loop. I will add counter equals 1 to 10 after for. This tells the data logger to perform a task 10 times each time the program encounters the loop. The action I want to repeat 10 times is to add 1 to the loop test variable. So I will enter loop test equals loop test plus 1 between for and next. This will add 1 to loop test each time through the loop. Since the loop will run 10 times on each scan, a total of 10 will be added to loop test each time the program scan is executed. An important thing to know about loops is that they do not run on the scan rate. Instead, the data logger cycles through the loop as fast as its processor allows, until the loop reaches a specified number or encounters a condition that tells the data logger to exit the loop. I will see this occur when I compile the program and send it to the data logger. Now, when I view the public table, I see the loop test variable is jumping by increments of 10 because the loop is running 10 times and adding 1 to the loop test variable each time it runs. This tells me the loop is working correctly. The loop is running too fast to see the individual increments of 1, but notice the counter is at 11. This is because the for loop must pass the last value in its range before it exits the loop. So as soon as counter reaches a value greater than 10, the loop is exited and then repeated when the loop is encountered again. Let's look at what happens when I change the for loop from 1 to 10 to 1 to 20. I will resend the program and then verify the loop is working correctly in the public table. Now I see that the loop test variable is incrementing by 20 because the loop is running 20 times on each program scan instead of 10 times. Counter now shows 21 because 20 is the last value in the loop's range and it must pass 20 before the loop is exited. Then the loop is executed again on the next program scan. In summary, for next loops are easy to configure and are a powerful way to repeat tasks in a program a specified number of times. Another type of programming loop that is used to repeat a block of code is a do loop. Do loops are used when a task needs to be repeated only while a condition is true, or until a condition is true. To demonstrate do loops, I will add a couple of new variables named mainScanCount and doLoopCount to the program. Again, these are counters, so I will declare these variables as type long. Then, right under scan, I will add mainScanCount equals mainScanCount plus 1. This will increment a mainScan counter each time the scan runs. For this demonstration, I will use the thermocouple temperature, TCTemp, as the condition that will trigger a loop. For test purposes, I will comment out the TCDiff instruction so I can enter the temperature manually in Table Monitor. Next, I will set up a do loop to repeat an action in the program. First, I will add a do statement on one line and loop on another line with some blank lines in between them. Any action I place between do and loop will be performed each time the program cycles through the loop. The action I will perform this time is to add 1 to the doLoopCount variable on each loop, but I only want to perform this action when TCTemp is greater than 30, so I will add a while declaration after do and a logical expression after that to control when the loop runs. The expression is while TCTemp is greater than 30. So now I have do while TCTemp is greater than 30, doLoopCount equals doLoopCount plus 1, loop. Next, I will send the program and see what happens with the counters. I see that the main scan counter is incrementing once a second, but the do loop counter is not incrementing. This is expected because TC temp is currently less than 30. Now watch what happens when I use Table Monitor to change the TC temp to a value greater than 30. Now, the do loop counter is running as fast as the processor will allow, and the main scan counter is not incrementing. This is because the program is stuck in this do loop, and no other code in the program will run while this loop is executing. This is an important thing to know about using loops in programs. If a mistake is made in a logical expression or an exit condition is not set, the program may get hung in a do loop. If that happens, check the logic in the expression that is controlling the loop to make sure the loop is exited at the appropriate time. This may require an exit do declaration, which I will discuss soon. In this example, as soon as I set TC temp to a value less than 30, the loop stops running and the main scan runs again. Notice that loop test is still incrementing by 20 because my original for next loop is executed on each program scan. If I want a do loop to run only until a condition is true, I can change do while to do until. To demonstrate do until, I will comment out do while and add do until do loop count is greater than 1 million. Remember, commenting out lines of code is a great way to test different variations of a program. Now I will resend the program. In Table Monitor, I see that the do loop counter only increments until the do loop counter is greater than 1 million, and then the loop is exited and the main program scan runs again. If I want the program to exit a loop based on a condition, I can use an exit do declaration. To demonstrate exit do, I will comment out do until and add a solitary do declaration on the next line. Then under do loop count, I will add if TC temp is greater than 30, then. And on the next line, I will add exit do. Note that exit do is one word, not two. If I use exit and do as separate words, I may get unexpected results. Finally, I will add end if on the next line. So I have do loop count equals do loop count plus 1. If TC temp is greater than 30, then exit do, end if, loop. Now, I will resend the program and view do loop count in Table Monitor. In the public table, I see the do loop counter incrementing as fast as the processor can run without ever exiting the loop. But when I set TC temp to a value greater than 30, then do loop runs once each time it is encountered in the program scan, and then it reaches exit do and moves on to the next line in the program. So now, each time the main scan runs, both the main scan counter and the do loop counter increment by 1. In summary, loops greatly increase the efficiency of programs because they allow code to be written once and then reused as many times as needed. Loops also execute tasks as quickly as possible at precise times based on where the loop is placed in the program and what conditions are used to enter and exit the loop. In this demonstration, I have shown how to use for next loops to repeat an action or group of instructions a specified number of times, and how to use do loops to repeat a block of statements while a condition is true, or until a condition becomes true.